Hello, you're listening to the Streaming Audio podcast, and today we're talking about the realities of going into production with an old friend of Streaming Audio's and an old friend of mine, Jason Bell. One of the things that makes Jason interesting is he spent a lot of time with Kafka from an unusual angle to me. He doesn't so much use it as he makes sure it's available to be used. He's the operations guy. He spends his time planning clusters and setting them up, maintaining them as they live and grow, and understandably, he's developed some hard-won knowledge about where it can go wrong and what you need to watch out for and what you should plan in advance. So we thought we'd get him in for some advice. And he has battle scars, yes indeed. He has scars for the whole system, from brokers and topics to Kafka Streams and connectors and ksql. And we start with one of my personal favourite axes to grind, understanding your data model. We should probably actually ask him to write a blog post about that one day. It would make a good guest post on Confluent Developer, which is our education site, where we put everything from blog posts and old episodes of this podcast to free courses covering Kafka internals, security, stream processing, and lots more. You can check it out at developer.confluent.io, but for now, let's get the episode started. I am your host, Chris Jenkins. This is Streaming Audio. Let's get into it. My guest today is Jason Bell. Jason, welcome back to Streaming Audio.
Thank you, Chris. Thanks for having me.
Good to have you. You're a return guest to Streaming Audio. This
is my third time.
Third time, yeah, but your first time with me, so behave.
Let's try. Let's see where we go. Is this the reason that Tim left? He just ran off?
There is rumour that Tim Berglund was broken by this time. But, you know...
understandable.
We'll find out if I'm made of more resilient stuff on the Jason Bell axis, and we'll see how it goes.
Well,
but you and I...
considering how much time we're already into this, in the edit, we're doing well.
Yeah, we're doing well. But you and I have a background, right? That goes beyond Kafka, because... we first met years ago at Closure Exchange.
2016, if I believe.
16. Right. That's a long time in internet years.
It's a very long time in internet years. And it was around about the time when I started using Kafka. But
really?
Yeah, it was. Yeah, I'm quite old.
Yes.
No.
Oh, I was a bit too slow on that. No, you're not old, honest.
Stop. You're old. Okay.
Yeah.
So, 2016, I was doing a talk at Closure X about a technology called Onyx, which was a peerless distributed system.
Sounds familiar.
And it could read from Kafka, and that's why I was interested in it. So, and it was built in pure closure, which was really, 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 really interesting to me. Oh. And as you are well aware, I was working with a lovely gentleman and still dear friend of mine, Bruce Sterling.
Oh, the amazing.
Yes, the amazing Bruce Sterling. We're trying to get that changed by Depol.
Yeah. If you don't know Bruce, if you're listening to this and you don't know Bruce, he has been the beating heart of the London closure scene for a long time, and he's a great guy.
There's a good group of people around all of that still.
Yeah.
So, and I still use Closure on a daily basis for my own stuff. So, I'm still involved, kind of. That's how I know. And you were sat on the front row, not heckling. That came later.
I'm a front row, pay attention kind of guy.
In all fairness, most of that audience were, because that was the first time I did that talk, and then 3 years later they were heckling me. It was hilarious because I actively encourage heckling in all my talks, as you are fully aware. It's all good fun.
So, take me on the journey from 2016. You first discovered Kafka to where you are today.
So it was actually working with Bruce that I got into Kafka. So we were supporting a customer who was sending quite a lot of data through and then using Kafka for it. So it's just one of those things I picked up. And this was this was early Kafka. This was log messages still being stored in ZooKeeper Kafka.
Oh, right. Okay.
Yeah, so we're kind of going back. And there was no streaming API. There was no Kafka Streams. There was no There was no Kafka Connect. There was no KSQL or anything like that. It was just here's brokers, here's ZooKeepers. Messages didn't even have keys at that point.
Gosh.
That's how far back we're going. So it's been interesting. I've been my journey through Kafka, and I think Tim and I spoke about this as well. I've watched these technologies come and get added to the ecosystem, and it's been really interesting. Considering, things like the streaming API was really important to me. And from the streaming API, one of the first jobs that I built, and I actually did another ClojureX talk on it, was how I bled all over Onyx. I think that's what we called the talk, because I was pushing way too much data through Onyx. To be fair, I'm breaking it left, right, and centre. And Kafka Connect didn't exist at that point, so I was using the streaming API for writing persistence out to sync stores like S3 or databases, that kind of thing. So they were all handwritten at the time, and then Kafka Connect came out, and then KSQL came out. I saw Michael Knoll do the KSQL demo at Strata Data Conference, the O'Reilly Conference in London, and he managed to write off 80% of my streaming API jobs in one talk. I was like, that's my career over.
That's a mixed blessing when those things come along. It's like, all my work's going to disappear, and that's good and bad.
And, well, interestingly, I became more known for being able to run Kafka than necessarily do development work on it. So I came to a fork in the road where I was doing less development and more advising on putting the clusters together. And that's how I landed the gig with Digitalis in 2019 as a Kafka expert. So I've been working with them for the last 3 years, and I just finished last week. So and I'm now working for a company called Dataworks, who don't use Kafka, they use Pulsar.
Oh, interesting.
So
we're going to stay on the topic of Kafka for now, unsurprisingly.
Yeah.
So,
well, it's kind of contractually the way, isn't it?
Well, it's not 100% guaranteed, but we do have a natural gravity towards that topic.
I think the shareholders may approve of that.
Yeah, in the long run. But the question is, do the listeners approve? That's the big question that we always focus on. But okay, so we're going to talk about Kafka. Tell me about Digitalis first. Why were they using Kafka? What do they use it for?
Well, they were a managed services company, so a lot of their clients were using Kafka.
Okay.
So that's how I landed with them.
So you must have ended up planning a lot of different clusters for them.
And a lot of throughput conversations and a lot of design work around data. Well, once we start talking, you probably get the picture that I'm quite a pen on paper guy, and it's like I need to know the process from one side to the other. Where does the data start and where does it end? And where does Kafka fit in the middle?
Okay,
that's the way I see things. So we planned a lot of things around that. We've done custom development work as well. And just as I was leaving, Debezium was coming up in conversation an awful lot as kind of the next thing for change data capture stuff as well. So I had a great time with Digitalis. They're a great bunch, but I decided it was time for a new challenge and time to move on.
We all hit that point in our careers. And the best thing you can get is like you're moving on for good reasons.
Absolutely, right? And I am on this one, definitely. I mean, I love the team at Digitalis. They're a fantastic bunch. And they're one of the rare companies where I cannot say, hand on heart, I never had a disagreement with anyone in 3 years. It was like everyone was professional, knew their stuff, and just put the customers first. It was brilliant. And that's rare. I've found in my career anyway.
Yeah, it can be a roller coaster at times.
It can be. I've worked with some very good companies. I've worked with some very bad ones as well.
Well, let's not go on to that because whenever you get enough,
because you'll get me to start naming names, and then I'll have lawyers and things like that.
Programmers have those conversations a lot, but they're not recorded and they're not broadcast.
There should be a speakeasy for developers somewhere.
There probably is somewhere.
It probably is. We don't know about it, though.
Well, if we did, we couldn't say, right?
Or if you know about it, what have you said about me?
Moving on. So, because this is what I really want you to tell me. I want you to teach me about planning a cluster.
Ah, right. Pen and paper. There you go.
Yeah. No, come on.
Any questions?
A great many questions. Thank you very much.
Okay.
So, I mean, where do you start? New client comes along. They've got to plan a cluster. Where do you even begin?
I deep dive on actually what the data is. I go a step before and say, what is it we're actually dealing with here? And that's actually quite a relevant conversation now based on just what I said about Debezium. It's like, if we want to acquire data from a database, then, okay, Kafka Connect's coming first then, with Debezium obviously being a connector. And I drill down to the very core components of, well, what's a message? What is it? Is it a JSON thing? Is it just a straight piece of text? Is it, could be an image. Nothing to stop me sending an image through Kafka. And have those conversations first. And then it becomes, well, how many you're sending? Because I noticed, and I did a Cleveland meetup during lockdown. Because Dave Klein kept asking me to do meetups in Cleveland, just so I could say hello, Cleveland.
Oh God, of course, that's why you did it. Of course,
I had to. I just had to. It was great. No, I think 3 people got the joke, but it was great. I was happy.
Well, with a bit of luck on this podcast, another 3 people just got that joke. So
we'll put a link in the
that brings your annual audience total up to 6, 7 if you include your wife.
I did that at a talk. In Northern Ireland, someone fell off the chair. There's one person in the room who got it and they fell off. It was hilarious. Anyway, so data, what is it? What size is it? And how's it shaped? How many you're sending? And at that point, you start getting a picture. And one thing I have learned is there's a lot of instances where the first question is, and please don't take this the wrong way, do you actually need Kafka?
That's a very fair question.
Because volume, we're talking about a volume game here. And we're talking, we're usually talking megabytes per second. And I know a lot of institutions, companies and clients that have not gone through that volume at all. And the question then remains, well, why are you doing it like this? What's the base reason for doing it? And some of them are legitimate. It's like, well, we have this source of data, but we have all these different departments that want to consume this data. Okay, all right. Or there is the argument of, there's this data, we want to transform it, we want to do X, Y, and Z with it, and we want to persist it out here. So that's where I start. I try and get an end-to-end of what's actually involved, because, like I was saying at the start, Kafka's evolved over the last 7, 8 years, especially with the amount of tooling that's been built around the core concepts of the brokers. So when I came on board originally, it was, well, there's these brokers and there's these messages and they go through and you monitor ZooKeeper with your life and then that's it. You may laugh. When it goes wrong, it goes wrong.
No, I can believe, yeah.
So when things like the streaming API came along, it was like, well, that means we can do this. And then there's transforms and filtering. Now it gets interesting. We can and then with Kafka Connect, it's like, we can sync out to this. Well, that's great, but that comes with a whole different set of considerations to make, especially when there's side-affecting things like database connections and HTTP endpoints with rate limiting and all that kind of thing. So there's a lot of things that people don't talk about. It's like we had clients that would persist out to Splunk, for example, via HTTP. And we used to just DDoS Splunk.
Yeah, I can see how you manage that. Yeah,
it's not the done thing. It's quite impolite. You lose friends very quickly. It's a lot of Christmas cards to write later on in the year. That kind of thing.
I think there's a connector for that.
There probably is now.
The Christmas card sync, yeah, that would be
the Christmas
perfect.
card sync, right? Okay.
Yeah.
The source connector of how many people I've offended this year will automatically create the Christmas card for me and send it out. I like the sound of that already. There's probably a talk in that somewhere.
Yeah, actually. No, actually, you technically could do that with something like Moonpig.
Hey, that'd be fab.
That would be a really good, like curveball conference talk.
Keep talking. I've got a VC in mind already. So yeah.
Okay.
That kind of thing. Anyway, so going back to cluster planning, he said,
start with the context. That's your number one tip.
Absolutely, and start with the customer. Start with the customer context, and be honest. If you think it's not a thing for Kafka, then say so.
Yeah, I mean, there should be a good reason for all the technology we use, right?
Yeah, absolutely, and I think pre-Confluent Cloud, obviously, it's now a lot easier in order to scale up something on the cloud and be metered gigabyte per month or however. But I'm so used to on-prem stuff, and costs a factor.
Yeah.
So even a base cluster would be 3 ZooKeepers, so you've got quorum, 3 or 4 brokers, and then you'd have 2 Kafka Connect nodes, 1 active, 1 back, distributed standby to take the load. Same with Schema Registry. If you're in a Schema Registry, you'd have those behind a load balancer, 1 active, 1 on standby. And then there's Prometheus monitoring, Grafana, alerting. And so the next thing, what seems to be a fairly simple thing of 1 or 2, what you think is, we'll spin up a Kafka cluster, has now become 15 nodes and is costing X amount a month. Yeah.
If you want the whole thing to be redundant, then
it's going to
cost. Those numbers add up. Yeah,
they do. And I'm not going to say it's something we don't talk about. It's just something I don't think we highlight enough. Put it in the cloud. Yeah, the 5 words that I hate most of all are put it in the cloud. That's it.
You got to justify that. Come on.
It's just a bunch of servers, isn't it? How can I put it lightly? No, I mean, the clients I've worked with have all got sensitive data, so it's not going to go onto the cloud. It has to be run on-prem. With big concrete walls and men stood next to it, and people, not men, with spanners and axes and spades and stuff, just protecting the data. I don't think that actually works in banking, but I don't
think that's how data security is generally done. I think you're thinking of Dungeons and Dragons, but that's another podcast.
So anyway, we rolled a D20 to see how many brokers we need, and that was swift. You've got to admit that was swift.
I like that. Yeah. And I've heard of worse planning strategies, but
you know what? It's not a bad one.
No, okay, I'm going to push you onto some serious planning strategies for broken numbers.
Yeah, all right then. 4's always a good start. 3's a good starting point. Obviously, you need a leader and a follower.
Yes.
And then add another one. Because if you've got 2 and the follower goes, or the leader goes, you've got 1 leader but no follower, it's not going to end well. It won't end well. So 3 is obviously your magic number to start off with. Same with ZooKeeper, quorum, 3 at the minimum.
Same with the monarchy. Air and a spare. That's what they say.
I've never heard that before.
If you're not. That used to be the rule for having royal children. Air and a spare.
So that's why you went to California. Okay. Where were we before you said that?
3 being the magic number.
This is going so well, isn't it?
We're roughly on the rails.
We are. Well, I'm against them at the minute, but anyway. So 3, back to 3. That was
3.
it.
3.
Leader, 2 followers. Can take a follow out and still maintain a cluster. It can still work. That's what we're after here. Things like stretch clusters, 2 DCs. So data center A, data center B is fine. You can have 2 brokers on each and take a data center out, and you'd be okay. There's topic considerations to take into account, minimum insync replicas of 2 and all that kind of thing.
Mm-hmm.
Which when we go through the planning, we go through all of that as well. The conversation then really, when you have 2 data centers, is what happens with ZooKeeper. So you do actually need a 3rd data center for your quorum node. So you can have two ZooKeepers on one data center, 2 on the other, and then the 5th or a 3rd, or how many, your quorum one, in a 3rd data center somewhere. And whether this is on-prem or on the cloud doesn't really matter. It's just the numbers have to work out in that way. So that's kind of the conversations we end up having first.
Okay.
And
do you always do it that way? I mean, would all your clients want that level of high availability?
Yes.
Always?
Mm-hmm.
Fair enough.
It's the nature of the data.
Yeah.
And this is it. I mean, it's like going back when I was working in Bruce, for example, we put a project together for a company. It was a proof of concept. I've done a talk about it. Actually, I've done another Confluent meetup talk. I can't even remember what I called it. Anyway, this was originally the How I Bled All Over Onyx talk. This was a talk about putting this cluster together that completely failed. I rewrote everything in Kafka Streams. I didn't tell Bruce about it till the day after, because that's what you do with CTOs. You just don't tell them.
Need to know basis.
Absolutely. I'll tell you when you need to know. It's working now. Now I'll tell you.
I can neither confirm nor deny that I've employed that strategy.
Well, that kind of says it all, really, doesn't it?
We've all been there.
We've all been there. It's the nature of the job. It's just we don't tell customers, too late. So, we had Onyx jobs running. They were failing, and it was my fault entirely. I was just pushing too much data through. And these files were gzip files of CSV data. Now, you don't know how much CSV data because of the nature of the data. Okay, it was flight search data. So you don't know if it's a small airport or a big airport. So you might get 3 rows or 20,000 rows.
Right.
gzip. So therefore your message size concertinas in and out per message. And Onyx couldn't hack it. And I'm not surprised Onyx couldn't hack it. And I spoke to Michael and Lucas about this quite a lot, and bless them, they spent the time with me going through everything, and I learned so much about closure and the error on binary transfer protocol, which is also well written. And there was all these little settings. This is how you get into the nitty gritty of stuff. And the same with Kafka. Is when you start, for better term, bleeding over everything, and it's broken, and you're trying to figure out what's going on. This is when you do most of your learning.
That's exactly how I learned Nix. By bleeding all over it and scar tissue.
Exactly. So, and this is how I learned Kafka. It was just on, it was cold-face stuff. And like I say, at that time, the cluster revolved around the messages being stored on ZooKeeper, which is like also another complete pain point for Kafka 0.8 back then. So ZooKeeper would fill up, and you go, "What's going on? Why is it all died?" And then, and it was in Mesos, so all we did was just tear the whole thing down, bring it all back up again. Anyway, the point I'm getting to is SLAs basically.
Yeah.
The SLA for this proof of concept was only 9 till 5, Monday to Friday.
Right. Which
is all very well. It's what they're paying for. It doesn't bother me. They just have to be aware of, well, what happens when something goes down, if the database connection got S3, or, because S3 drops, Amazon endpoints drop, they do, it's a fact of life. What do you want to do if this happens? And we sat down and went back to them. Bruce and I went back and said, look, the biggest period of time you've got between something failing at 5 o'clock is Easter. So you've got Thursday night, Friday, Saturday, Sunday, Monday, and then we're back in the office 9 o'clock Tuesday morning.
Right,
if the failure between that point and that point, you want to save the data. And we calculated the amount of of storage that they'd need in order to volume. And the volume they were predicting, because of the nature of the data, was 12 terabytes a day.
Crikey.
Yes, it was quite a lot.
This is all flight data?
Yes, it's all flight search data.
Okay.
So I won't say from whom and I won't say for whom, but that's what it was.
Right.
So, yeah, it was like, and then you've got replication to take into account. And you think, well, the next thing is we need around about 280 terabytes for 4 days. That's going to cost.
That's in 2016.
Yeah, 2016, 2017.
Yeah, I mean, even today, that's a cost, but back then.
It's a cost, yeah. And it has to be taken into account. So, and then, if you had a problem 1 minute past 5 on a Thursday night, and you have 280 terabyte to deal with when you power everything back up on Tuesday morning, you've then got this has all got to go through again.
Yeah.
Before, so you've then got this back pressure problem as well. So yeah, it's all those kinds of considerations. We've moved on now. Obviously, topic data is held on volumes, not in ZooKeeper, but you still have to plan that kind of thing. I have alerts set up at 50% disk volume because I'm paranoid. Because what we found at Digitalis is if someone does stress testing, they don't know what they're stress testing against. If you default to 7 days retention, you can fill up brokers really quick just by stress testing. I'm going to send 1 million messages through, even though my prediction is 4,000 a day. Fine, okay, but you're going to fill my test brokers up, and I'm not going to be too chuffed about that. And it has.
Yeah, I suppose it's in the nature of stress testing that you're trying to find out what breaks first, right?
Yeah. Usually my resolve. I'm good for a quote today. It's those kinds of things you need to take into account, and the stress testing does come with its own set of problems. Now we know in Kafka there's the producer performance test tool and the consumer performance test tool, and they're great. But something I said in the very first podcast, which I think might have surprised Tim at the time when we were talking about it, is not to assume that everyone knows how Kafka works. You have software production teams that are building apps to produce and consume from Kafka, but they may not necessarily know how it works. They don't need to know how it works. It's like, here's my producer, it sends a message. Okay, I'm going to send 20 million and see what happens. Do I get Axe back for all of those? Or is it just fine and forget? And those kinds of things. And that's all very well. Be handy if you told us, Right.
So you've got to do kind of capacity planning for the people that don't know what they're actually sending. Yeah,
absolutely. So what we ended up doing at Digitalis was a sheet of message size. How many a day? Is there a peak time? This is my other joyous slide from the meetup was that this graph of volume over time, volume against time. Let's call it that.
Yeah.
And I think the misconception is when you're using Kafka, everything is just flat like that. It's a streaming data platform. There it goes. It doesn't. It does this. It's all over.
Yeah, of course.
It's all over the shop.
And different industries have different natural peaks.
Well, exactly, and so I'm using the full width of my screen here as a graph, so X and Y.
So that's going to be great for the people listening to this.
It is, isn't it?
Jason is drawing a graph with his finger, folks.
I'm very sorry. I'll stop doing that because that's just not really going to work. Retail, for example, you'll have nothing till 9 o'clock in the morning. You'll have peak traffic at 3 o'clock or lunchtime or what have you, and then it drops off at 6 o'clock in the evening.
Do you know what I was thinking about recently, which I just don't know how they plan this, is the music festival Glastonbury.
It's immense, isn't it?
Yeah, they sell nothing all year, and then there's like a 10, 20-minute window where they sell 200,000 tickets.
How?
And it's the most bursty traffic I've ever heard of.
So, I wrote a blog post in 2002 on that.
Oh, right.
And I can't even remember what I said. It was about Ticketmaster, and it might have been Michael Jackson tickets because people were struggling to get, because obviously systems just break. Ever an advert for elastic computing is that.
Yeah, 2002 though, you didn't have that many options, right?
No, you didn't. You didn't. You really didn't.
I mean, I remember 2002 as some people still advocating shell scripts as your main web server. That's how dire things were. And your traffic was limited by the rate at which you could fork a new shell.
I've never come across that before.
Afraid so.
Wow. I mean, I'm still a Perl hack at the end of the day as well. No, I'm serious. For big search and replaces in large files, I will still crack up Perl. I won't use Oracle Set. I still use, but it's just in my head. So anyway, it's this elastic. In terms of volumes going through, banking's an interesting one because it's like Hadoop. It just goes, whoop, and that's it. That's it for the day. Yeah. You just get this huge burst of traffic through at batch times. And are we treating this as batch, or are we treating it as streaming? And traditionally, you'll find a lot of organizations will just dump data into Kafka in one massive swoop, then let the brokers deal with the backlog and process everything through.
Yeah.
Fine. It's fine. It works. I mean, things like IoT data, car data, is just a huge volume game streaming continually while the car's moving. At high velocity, there's loads of it.
Not just the car, but the data coming out of the car is at high velocity, right?
Yeah. Telemetry data coming from cars is just insane. Loads.
Yeah, I can believe.
And there'll be more of it.
And that's too very bursty rush hours, right? That's got to spike massively.
Bursty hour edge computing, basically.
So what have you done to deal with those sorts of spikes in different industries?
I usually end up weeping in a skip.
I mean, it's a sound strategy. I was hoping for something slightly more technical.
It goes back to testing. It does go back to testing. I mean, we sat down with teams and said, okay, you're going to have to stress test all of this stuff out. But what we do is we change the retention time on the topic so you weren't impacting volumes of the disks.
Right.
So I don't delete topics. I flush them out. What I'll do is I'll change the retention time down to like 3 milliseconds, wait for Kafka to do its work and rebalance everything, and then bring the retention time back up to something sensible.
That's an interesting strategy. So for stress testing, you just make it a short-lived but identical system.
An hour.
Yeah.
Did the data go through? Did the consumers on the other side pick it up? It's those kinds of testing strategies, and also what I've impressed on development teams is when they're writing. So what I found is, especially in banking, obviously all these different departments. There might be credit, there might be mortgages, there might be all of this stuff. That a department writing a producer will not necessarily be testing what's coming out the other side.
Yes, yeah.
And it's the little things. It's not so much the technicalities of Kafka at this point. It's just human contact. It's just, well, oh, Jace, can you tell me how many messages have gone through? Well, no, I can't. I can't give you a definitive number of this amount. I can do that per partition, yes, but I can't give you an absolute total. There's only one way really to do that. Rob Moffat did a post on it, which was use ksql to stream in and do an aggregated count on the message going through.
Count them as they go through, yeah.
Yeah, that's the way to do it, but I can't do that. Plus, it's banking data, the nature of the messages. I'm actually not privy to the data. And right. I should not be privy to the data. I can't be. I've signed NDAs, that kind of thing. Yeah. So I can't see Mrs. So-and-so's mortgage payments go through. I just don't see that. I'm not allowed to. So the responsibility is on both teams to measure what goes out, what goes in, and that's another conversation as well.
Yeah, because that is a tricky thing to watch for. Right? There's a great thing that you can decouple producers and consumers, right?
Yeah.
One department can write, many other departments can read, but it does introduce the problem that you've actually got to have someone in the writing department checking that it's useful.
Yes. Yeah. Is the data correct? Did it deserialize properly? And once you start putting these things in place, then latency becomes interesting as well, because then have you got performant consumers? Do you have enough consumers running against partitions? If I want to, and we don't think, I mean, while the main metric for Kafka is megabytes per second, I don't think developers think of it that way. They think of how many messages I can process, but they don't think in megabytes per second or anything like that. So there's no real consideration about network traffic going through in terms of saying, oh, I need to process 3 megabytes a second or a gigabyte per second or whatever. I need 50 consumers. No one really thinks like that. I can guarantee you most people will only put 10 consumers up at the most, and the partition count will be fairly low to start off with. Because obviously you can go up, but you can't go down. These all feel like old school things, but they're still really important to me.
Because I think as programmers, we have a tendency to assume that it's an entirely logical level analysis.
Yeah.
Until we get problems, right? The network is perfect until you find it isn't, and then you start thinking about it.
So I always think about latency in terms of, well, you've got compression on the producer side. If the compression doesn't match on the consumer side, then that adds latency. It's also fun from a broker's point of view, because it has to obviously decompress the message, rewrite the metadata, add a key, add a timestamp, compress it back down again, then send it through. Anna Badal and I have spoken quite a lot about this. So, and then you obviously got Schema Registry stuff, and then we get to Kafka Connect.
Oh, yeah.
On the sync side is an interesting conversation completely.
And for those of you not watching, Jason has just completely broken down at the thought and fallen off his chair, and he's back.
Hi.
Tell me about that.
Yes, I'm here. I'm okay. Source connectors are not a major problem. Never really had any problem with source connectors and things like the main connector I ended up working with obviously was the sort of the JDBC connector. People like reading stuff from databases and sending it to somewhere else. It seems to be a hobby.
It's an obvious use case, right?
It is. It is absolutely. So Kafka Connect sync side. There's a bunch of considerations to take into account, not necessarily on the capacity side, just generally. If it's schemaed, then what do we do on message failure? What do we do on conversion failure? Because obviously, if you're running DLQs, if you're running dead letter topics, dead letter queues, that's a different argument. What are we going to do with those messages if they end up in there? I know a lot of people that put messages in dead letter queues and then never read them again. It's just
find out 6 months later, what are these 200,000 messages doing?
Yeah, and also they were quite important. Because it was a process of open account, send money to account, close account. We didn't realize they closed the account. It's really interesting. So the two conditions, I think the API may have changed since. I know there was a kit for it, I'm fairly sure there was. Conversion and transformation were kind of the two things where if there was an exception thrown, then the message would go to the DLQ. Fine. Question one, what are you going to do with the DLQ? Are you actually going to read it, or are you just going to ignore it? We used to set up Prometheus alerts on DLQ, so if more than 10 messages went in, it would actually alert us and say there's a problem here. And the reason for that was if you have something side affecting like writing to a database table, your connector is obviously connected to the database via JDBC.
Yep.
Networks fail.
They do. They very much do.
And they don't necessarily come back up the way you want them to. And therefore, Kafka Connect is kind of just sort of flailing around and going, yeah. Because error tolerance equals all within a Kafka configuration is great, but everything just carries on like nothing had happened. And there was no capture. Now, this may have changed, hence me mentioning a kit, because I remember seeing it. That when you push your message to the sync, if it threw an exception there, you really didn't have much choice on what was going to happen next. If your error tolerance was all, it would just process the batch and keep going. So if the database was throwing an SQL exception back, it didn't care. The offset would get updated, and the data wasn't written to the database. So anyway, retry logic, yes, that's fine, but you can go through 10 or 20 retries pretty quickly, and the whole thing's collapsed. If you let your retries carry on over like a minute, then obviously you're starting to get back pressure from the brokers. Not a big deal, but what I've found is monitoring Kafka Connect is not everyone's biggest priority. They tend to just focus on the brokers and not the connectors. So when a connector fails, which is actually another interesting point, the logging for Kafka Connect is central to the node. It's not to the worker. If we could branch out worker level metrics and worker level logging, it'd be far more effective, because then I can look at the logs for that worker and go, it failed because of this. Because what happens, say you have 20 workers running on Kafka Connect, your log files are massive at that point.
Right.
And then to go and root through, I know people that won't pay for Elasticsearch. So, my superpower is to be able to read through raw log files with grep.
Grep. Everyone has that in their back pocket sooner or later, right?
You need it. And my advice to anyone is to go with the tools that are available to you for free without paying for, and learn those first. Learn the CLI, learn to read the logs in a terminal window when you need to. Because when all the cloud services vanish and disappear, and that's all you've got, and you need to fix it, that's where you start. So I've always made those things my friend first. And me and Kafka Connect logs are really friendly now. We know where to look, and we know where to go. We know where things are hidden, and bringing up connectors and just watching everything go through to make sure everything settles down is actually quite an important job. And it's one that not many people talk about that I'm aware of. Or if they do, they don't blog about it, or they don't shout about it or anything like that. They're probably just weeping in the same way that I do.
Do you have any good tips for monitoring connectors?
Bash scripts do work. No, I'm not joking, actually. The bash scripts, I would write a bash script to go through the active connector names. So, was it /connectors? So, curl just /connectors. And I'll tell you the connectors that are running. And then use sed to then parse out those names, the connector names themselves.
Yeah.
So it meant if connectors were being added and removed, then you weren't having to update files all the time. That was the reasoning behind it. And then do a for loop on each of those connector names, do a curl again, so /connector /status, /connector /the name /status, and that would tell you how many tasks are running and the state of those tasks and the state of the worker. And They should say running. If they say failed, something's happened. So we had a job that would do that every 2 minutes.
Right, yeah.
And then if it failed, we got alerted, then we could go and have a look. And then if it was... That was the best time to go and have a look at the logs, because otherwise you're like 30,000 lines down the chute at that point.
Yeah.
And then figure out whether to halt the connector, tell the client what do they want to do. And because interestingly, we found in a couple of cases, once a year, this would happen, that database tables fill up.
Yes. Yeah, they do. Yeah, I've had that a few times.
So your connectors are fine and writing data out, but the database isn't getting updated at all. So we used to get a request once a year about rolling back the offset to when the fault happened on the database side, and then having to replay everything over again. It does happen, and that's an art form.
This is a thing, right? You can test Kafka, you can test the connector, but sometimes testing the external database having problems is really tricky.
Network failure. Always test for network failure. Network failure on the brokers, network failure on ZooKeeper, network failure on any side affecting databases, syncs, sources, whatever. This is it. And it goes back to what I said at the start. If we're talking about end-to-end, Kafka's the bit in the middle, as far as I'm concerned. It's a tool. It's a great tool. I love it. It's done me well as a career for the last 6-7 years. but we have to think about the end-to-end and everything that affects it. And even coming back to capacity planning now, we've got the transaction API, which obviously creates a topic, which then is replicated, and there's more partitions, therefore there's more data. If it's a high volume topic with transactions, then you have to take that into account as well. RocksDB on stateful transactions in the streaming API and in KSQL. They can, global K tables copy across networks, not like,
Yeah.
It gets... There's a lot not talked about that we learn the hard way. And I'm only scratching the surface based on this conversation. And it is by a case-by-case basis. There has to be a bunch of KPIs to say, we need to know that most important metric to monitor, consumer lag.
Right.
Yeah.
Why is that the most important?
I want to know how far behind my consumers are. Because if they are far behind, and we're talking not difference between 1 or 2 messages, that I can tolerate. It's when it's 40,000 messages. That usually says to me is the problem. So, bash scripts for Kafka Connect, connectors, workers, but also run the consumer group list job and describe each consumer group, and that will give you the clients running, the offset positions, and the lag. And I used to do that every day. I had that as a cron job to run every day, and it would email me. So
you ran it in batch.
But I'm not allowed to touch the cluster. My job is to make sure the cluster's up, not write to it.
Right, okay.
So,
Black box testing of Kafka clusters.
My methods may seem archaic, but it's the only way we could do it.
I know there's someone who's mentally rewriting that script in Python right now. And there's someone else wondering why the API doesn't use GraphQL and you can get it all in one query. But in the meantime, a bash script will do the job.
I could say something really controversial, but I'm not even going to go there because I will never get left alone.
Oh, you've dangled it out now.
I have, haven't I?
Mm-hmm.
GraphQL, really? Sorry, said it. Python, really?
Oh, that's a much harder one to argue with when you're championing bash scripts. Let's not descend into a language flame war because
I learn whatever I need for the job. I mean, Dataworks, I'm learning Go. I'm on Go now, and I really like it. It took me a bit of a left at the lights with my brain because it's so functional programming with Clojure for so long.
Oh yeah, you've got to go back to imperative.
Yeah, it's like this is a bit weird. But I actually like it. Really like it. Anyway.
Okay. Well, I'm gonna just for balance, for journalistic balance, I'm going to say Go. Really?
Really? Rust? Really?
I've had some fun with Rust.
Yeah.
Yeah. Cool. I haven't dabbled in Go yet, but I've had some good fun with Rust.
You're a big TypeScript guy, aren't you?
Am I?
Well, most of the talks I've seen you do recently, they've involved that kind of thing, haven't they?
I guess my heart's in PureScript, but when you want to interact with the JavaScript world, which I often do, then TypeScript is where I head.
Do you want to know a secret?
Yeah.
I installed Emacs on Windows yesterday.
Different listeners will find different parts of that to be sinful.
I don't care. Anyway, where were we?
We were about to talk about the problems with streams, because that's another part of the picture you haven't talked about.
Streams are just as interesting as Kafka Connect, really, because their error tolerance is defaulted to all. It's very difficult to stop a stream. You have to have a really, really good reason for doing so. So DLQs work in the same kind of way. Now, there's an exception mechanism to decide what you're going to do with a message, but it's that long since I've looked at it. This is the interesting part of not doing a huge amount of development work for so long. When we did Kafka Jeopardy, so that was Neil Busing, Animadon, and myself, they knew all the development stuff and I knew nothing. Weird. but they didn't know the port number to ZooKeeper. So I came last, but I don't care. it was
this
fun.
is why it's an interesting perspective, though, right? Because you're coming at it from it's got to stay up, but it's almost a black box to you.
It is a black box to me.
Oh.
It is a black box to me, and it's like, oh, can we have a look at this message? And it's like, no, go and consume it. I mean, some support tickets, people just don't like me. They think I'm being difficult. It's like, no, this is really hard to do. So running Kafka with a set of blinkers on, basically, it's like that. Sorry for those not watching. I'm putting my hands up in blinker fashion.
He's miming a horse.
Nay. That could have garnered a laugh there, Chris. To be fair.
Oh, I'm not sure it could.
Go on, you can do it. I've totally lost my train of thought now. Streams. That was it. Streams have been difficult. I found difficult. I mean, actually, Neil Busing is probably a really good person to ask, and so is Anna, on how they would handle it. So, Anna, Neil, how would you handle it?
We'll splice their answer in later.
Leave a comment.
Okay, let me ask you this then. Have you found that streams or KSQL work better from an operational point of view?
Oh. I prefer streams.
Not the answer I was expecting.
I see the logic and the appeal of KSQL. Do not get me wrong. I like streams in small container services run separately. Because if you have a stream that's hogging the resources of a node, the other application tends to struggle. So you may have a network-heavy streaming job, and then which also may be CPU-heavy, depending on the transformations and things that are going on. And if you have another one that's just doing some sort of fairly basic aggregations on a fairly low level, low velocity topic, kind of gets put back at the queue.
So you're saying that it's easier to manage individual streams processes if you split them out that way?
Yes.
Yeah,
I think so.
Because KSQL, it's all kind of sitting there in one lump. Yeah.
And you have that same problem that if you have a KSQL query that's really intensive, then it tends to hog the resources. So
I've not thought of that, but there is that to be balanced with the convenience of KSQL, right?
Yeah, it is there. It's I won't call it an issue. It's just a consideration.
Right. Yeah.
And it all comes back to design again. It's knowing the data that's passing through the system, and if you can start with that and you know the domain, and actually, a good point in question. If you bring domain knowledge in and don't assume that you're going to have an easier ride with all of this. It's like if you're in retail, it's like, well, how many transactions come from a POS system per hour? Oh, right. How many basket items is that? Well, yeah, okay, it's this many and it's this size. All right, well, we can model that then. We can work it out. Even with a calculator, you can work it out.
I would have thought a lot of customers don't actually know that data.
Some do, some don't.
Okay.
But there must be a way of finding out. The data's got to come from some point. There's a starting point somewhere.
Yeah.
And it's just a case of knowing which person to ask, not a case of it just not knowing. If all right, let's take an example. POS data is actually probably a good one. Within a basket, there's n number of items. That could be 2K in size or 10K in size. But we've got a lower and upper bound that we can work with. I'm now doing dancing with my hands. Sorry. But we've got a lower and upper bound of size. And even if you then say, okay, let's double it, so we've got some contingency. This is another thing where people go, oh, it's not going to be any more than 10K. That's fine. And then we start seeing 30K messages being pushed through.
Yeah. This is the old thing of order of magnitude planning, right?
Yeah, exactly.
Yeah.
So I always put like a 50% in minimum contingency for sizing, especially when it's high volume and across a large cluster. And, The other thing to keep in mind is, I've probably said that 100 times in this podcast so far. The other thing to keep in mind,
There's a lot of things to keep in mind.
There are a lot. Something to write down then, and not keep it in mind, because that's the worst place you can keep it. If it's a shared service, you have multiple departments writing to the same Kafka cluster. Some departments are going to write more data than others. And it's very difficult to know the performance of the cluster when there's so many different tenants of that cluster. Not everyone has the luxury of having their own cluster, basically. Quotas are important, but that's a post-production thing.
Okay.
You'd measure it afterwards. Anna might actually argue with me on that one, because she's a quota. She's the quota queen. Let's call her the quota queen.
I'll check with her how she feels about that nickname.
She's going to throttle me after that one.
Well, that seems like a quota issue, throttling. Yeah, I went there.
You went there. You went there. That's really good. That's good. This is turning into the Mighty Boosh, isn't it? It's just like, So quotas are important, but I find them very difficult to monitor in the first instance. You won't know until the team's gone live into production, and then you're just looking at the network traffic. Hence, Grafana is really important
for getting those messaging graphs in real time. Yeah,
bytes in and out, and seeing how things actually look. That will govern the quotas. And so topic level quotas don't exist anymore. Well, they're being deprecated. So it's really on the producer and the consumption side, mainly on the producer side, to stop all that stress testing kind of volume going through. You do get bursts. You have to plan for bursts happening. At least with the quotas, it will throttle. It won't just shut down. Yeah, you have to give it some fairly amount of data in order for a quota to completely block you out and throw an exception.
Right.
But that's where the performance producer tool comes in on the command line. You can at least say, I want 1 million messages every 10 seconds of 100K in size. Go at it and see how it performs.
So to wrap this up into a TLDR, if we can, we're saying, as much as you can, get the picture of your data and your data model before you even begin.
Absolutely. It's an end-to-end process. It is a process. I like to think of it as like a graph, point to point to point to point to point. Because a direct graph is nice in the sense that things will split out. You might have a process where the data splits out in ksql into a new stream, or streaming API job into another topic, or for that kind of thing. And they all have considerations down the chain. So things like RocksDB on the streaming side, and if you're creating a new topic out of the streaming API, how's that replicated? How's that partitioned? What's the throughput of that? What's the volume of that going to be? Is it going to be 1/10 of what's coming through the streaming API job? I mean, we built some streaming API jobs to look at source data, because there was, like, say, 10 million messages a day going in, and we were only interested in 7 of them.
Right.
It does happen.
Yeah, I can believe that.
And it takes, there's 2 options at that point. You're either going to say, I want to filter it with a streaming API job, or I'm going to let Kafka Connect do all the hard work.
Yeah.
I wouldn't want Kafka Connect to be consuming like that. I'd let a streaming API job do the work for me, and then only persist what I need to persist.
Yeah. Until the day that you find that there's another type of message that you need to filter out as well, and then.
But it's an evolutionary process at that point.
Yeah,
it always is. I don't think anything sits still for too long.
Yeah, the whole of software is reacting to changing requirements. Right?
Precisely.
Yeah,
precisely. And these requirements can come. It might be a fortnightly sprint. I know some projects that take 2 years to turn around. It's the nature of the business, really, more than whether we do agile or anything like that.
Yeah. So know your domain, plan it out as far as you can, load test it before you put it in production, and write some bash scripts. Those are your 4 tips.
Well, now you've put it like that, I'm going to reconsider my career options. Thanks.
Well, if the bash scripts don't work out, you can always play those Chapman sticks in the background.
I love playing them. They're great.
Okay, we'll get you back in to record the outro music. But for now, Jason Bell, thank you very much for joining us.
Chris, it's been an absolute honour. It's good to see you.
Cheers, dude.
Thank
Bye.
you. Take care.
And there we leave it. You know, I'm going to confess I have this dream that one day, maybe at a future Kafka conference, Jason and I will be on stage playing a gig to close out the night, and he'll be on the Chapman stick and I'll be on the theremin. I don't actually play the theremin yet, but I can buy one and I will learn it if there is that slot available. You got to have a dream. For now, we're going to have to leave Jason to his cluster maintenance. Before you go, if you've enjoyed this episode, now is an excellent time to let us know. My Twitter handle's in the show notes, or you can always leave a comment or a like or whatever. We always appreciate hearing from you. Between now and the next episode, if you want to learn more about Kafka and how it can help you get your data moving, Confluent Developer is here to help you. Head to developer.confluent.io, where you'll find everything from getting started guides to architectural patterns. It's all free and it's written by some truly great minds that I'm very happy to work with, so check it out. And if you feel ready to use Kafka in production but you don't want to manage it yourself, head to confluent.cloud, which is our managed service for Apache Kafka. You can sign up and get a cluster running in minutes, and if you add the code podcast100 to your account, you'll get $100 of extra free credit to run with. And with that, it remains for me to thank Jason Bell for joining us and you for listening. I've been your host, Chris Jenkins, and I will catch you next time.